Hey guys, welcome back to Miss Cousin's geometry class. Today we're going to be completing CPM lesson 3.1.3. First, let's make sure we have all our materials. You will need your ebook, your notebook. It will be helpful if you have graph paper, but it's okay if you don't, and you're going to need a pencil. Go ahead and pause the video while you get your materials. Open your ebook to lesson 3.1.3 and then play the video when you're ready to get started. All right, before we begin, let's copy down today's learning target. I will use ratios to solve for missing side lengths of different figures. Pause the video while you write that down in your notebook and play the video when you're ready to move on. Okay, lesson 3.1.3, how are the figures related? Using ratios of similarity. You have learned that when you enlarge or reduce a shape so that it remains similar, that is, it maintains the same shape, each of the side lengths have been multiplied by a common zoom factor. You can also set up ratios within shapes and make comparisons to other similar shapes. Today, you will learn about how changing the size of an object affects its perimeter. You will also learn how ratios can help solve similarity problems when drawing the figures is not practical. So we're going to start here on problem 3-24. Says trace the rectangles below onto your paper. So if you have graph paper, that'll make this a little bit easier for you. If you don't have graph paper, that's okay. You can just do your best to either freehand them or you can try and trace them on your Chromebook, from your Chromebook. So go ahead and do that first. Pause the video, and then when you're ready to start letter A, you can play the video. Now, letter A says, show that there is a sequence of one or more transformations that can carry one rectangle onto the other. So if you think back to chapter 1, the transformations that you learned were reflection, rotation, translation, and now you also have a dilation. So in your notebook, write down the sequence of one or more transformations that can take this small rectangle and make it line up with the big rectangle. All right, for letter A, you could have put a couple different answers that might have been correct. Just make sure that you do have a dilation in there to show that the smaller rectangle had to get bigger to match up with the larger rectangle. So you could have said something like the smaller rectangle translated to the right, translated down, and then dilated, something like that. Let's move on to B, and I'm going to have you do B and C together. It says use ratios to show that these rectangles are similar. So figures that have the same shape, but not necessarily the same size. And then what other ratios could you use? So you're gonna do both of these right now. If you're not sure, look back into your work from lesson 3.1.2 from the last lesson, and that'll have some examples of what your ratios should look like. So again, press pause, complete both of those in your notebook, and then when you're done, you can press play. Okay, we're going to use some ratios to show that these rectangles are similar, and this is just like we did in lesson 3.1.2. So I'm going to give you two different examples for B and for C, and then you guys are going to go on and do letter D after that. So one ratio we could do the 7 and the 2. So I can put 7 over 2 equals 3.5. And we can do 21 and 6. And that also equals 3.5. So since they both have the same ratio or the same zoom factor, that's how we would know they're similar. And I'm going to give you one other example for how these ratios could look. Take those out real quick. Okay, so we have 6 over 2 equals 3 and 21 over 7 equals 3. Now you're going to go down to letter D. Lynn claims that these figures are not similar. When she compared the heights, she wrote 2 over 7. Then she compared the bases and got 21 over 6. Why is Lynn having trouble? So explain completely. So look at these two ratios. It might be helpful if you draw some arrows, kind of like the ones I have on here, but draw them to represent these two ratios. Pause the video while you do D. All right, so let's draw some arrows on here to see if we can figure out why Lynn is having trouble. Our first ratio says 2 over 7. So hopefully you drew an arrow kind of like that. And the second one says 21 over 6. So now since she has these arrows going different directions, she needs to flip one of her ratios so that they're in the same order.